Muito bom dia, pessoal. Hoje, 29 de abril de 2026. Pelo horário de Brasília, agora são 10 horas e 55 minutos. Estamos iniciando mais uma transmissão aqui no canal Will PTV. Meu nome é Horário Pessoa. Estamos, então, iniciando nossa transmissão ao vivo junto com a SpaceX. Hoje, então, com o Falcon Heavy, nova tentativa de lançamento com a missão ViaSat-3 F3, né, com um satélite. O horário do lançamento está previsto para acontecer às 11 horas e 13 minutos pelo horário de Brasília. Este é o lançamento número 51 esse será o lançamento número 51 da SpaceX, lá no Centro Espacial Kennedy, na Flórida, nos Estados Unidos, no complexo de lançamento 39A. Certo? Lembrando então que hoje com o Falcon Heavy, né, essa missão terá um torno de 4 horas, né, de duração. Mas aqui no nosso canal só iremos transmitir apenas o lançamento e o pouso dos auxiliares do Super Heavy, tá? Então fiquem aqui, se inscrevam no canal e compartilhem a transmissão. O IPTV sempre mostrando tudo o que acontece ao redor do mundo e também na Estação Espacial Internacional.
And welcome to SpaceX's live coverage of the ViaSat-3 Flight 3 mission for our customer Viasat. SpaceX's Falcon Heavy rocket is set to lift off at 10:13 a.m. Eastern from Launch Complex 39A at Kennedy Space Center in Florida. I'm Tyler Lionquist, a Starlink business analyst.
And I'm Amanda Ayers, a ground systems engineer. Thank you for joining us for our 12th Falcon Heavy mission. If you were with us on Monday, you'll know that we stood down on our first attempt due to unfavorable weather. The weather outlook today is again a watch item because there is a cloud deck developing to the north, so our teams are monitoring this as we head towards T0. The primary concern with this system is a fly-through risk, so we'll keep you updated as we move through the countdown. The good news is that weather is currently 85% favorable for launch. At this point in the countdown, if we are not able to launch today for any reason, the next possible launch opportunity would be as soon as 48 hours from now. And that's because Falcon Heavy has a longer recycle time than Falcon 9 due to how long it takes to re-densify this much liquid oxygen or make it cold enough to enter another attempt.
Today, we're launching the third of 3 ultra-high capacity satellites for Viasat. And once in service, ViaSat-3 Flight 3 is expected to provide more than 1 terabit per second of broadband capacity over the Asia-Pacific region, more than doubling the bandwidth capacity of Viasat's entire fleet of satellites and completing the Viasat-3 constellation. So while the countdown continues, let's take a moment to learn more about Viasat.
We're really excited today for the launch of Viasat-3 Flight 3, which is going to bring unprecedented amounts of bandwidth to the Asia-Pacific region. So Viasat-3 is a really good fit for Asia-Pacific with our forward-looking plan for these multi-orbit systems.
Mas faltam 13 minutos aí para o lançamento. Hoje aí com Falcon Heavy na tela, lá na Flórida, nos Estados Unidos. Estamos com 85% então de chance de ocorrer o lançamento na manhã de hoje. Lembrando que se tiver algum problema, né, com o lançamento, né, se não puder ser lançado, A nova oportunidade, então, será remarcada em breve, né? Então, estamos aguardando aí se vamos ter ou não lançamento. Acreditamos que sim. Vamos continuar acompanhando. Lembrando que esta missão, então, é ViaSat-3 F3. Lembrando que para esta oportunidade, né, a ViaSat está lançando, então, seu satélite que vai ficar geossincronizado lá com o pessoal da Ásia. Para quem não sabe o que é o Falcon Wave, né? Falcon Wave nada mais é do que 3 boosters do Falcon 9 em um veículo apenas, né? Então, ao todo aí são 27 motores, né, impulsionando aí o Falcon Wave, né, sendo o núcleo central e 2 auxiliares. 11 minutos para o lançamento.
Heavy back on the pad today. This vehicle was developed entirely by SpaceX as a heavy lift version of our proven Falcon 9 rocket. Its debut flight in February 2018 marked the first time a rocket this powerful had been sent to space by a private company.
Falcon Heavy is essentially 3 reusable Falcon 9 first-stage boosters connected together with the center core modified to withstand the stresses of the side boosters. This super-efficient design features the same Merlin engines, avionics, and systems that have flown hundreds of times on Falcon 9.
The first stage is comprised of 3 cores with 27 engines total and a 28th engine, a Merlin vacuum or MVAC, on the second stage. The side boosters are connected on the nose cone, the interstage, and the octaweb structure at the bottom of the vehicle.
Falcon 9 is the most launched rocket in the industry today, handling the majority of SpaceX missions, including Starlink deployments, crew and cargo flights to the International Space Station, private astronaut missions, and most commercial satellites. Falcon Heavy delivers significantly more performance for missions that require greater payload mass or higher energy orbits than a single Falcon 9 can provide, like today's Viasat payload. And as one of the world's most powerful operational rockets, Falcon Heavy is capable of launching nearly 64 metric tons, or 141,000 pounds, to orbit.
That's why Falcon Heavy is primarily used for large commercial communication satellites, national security payloads, and major NASA science missions, like NASA's Griffin Lunar Lander and the Nancy Grace Roman Space Telescope, which are both manifested for late 2026. Just earlier this month, NASA announced that Falcon Heavy has been selected to launch the Rosalind Franklin mission, targeted for 2028. And this will be the first Mars rover to search for life on the red planet's surface.
And it makes one heck of a Matchbox collectible. Check that guy out. Now, just a quick check on the weather. We are still at an 85% favorability for launch. So things are looking up.
Things are looking good.
So to date, Falcon Heavy has flown 11 times with 100% mission success. It's the first flight on February 6, 2018 that was a demonstration mission that carried a Tesla Roadster and Starman into a heliocentric orbit around the sun.
Seeing that first Falcon Heavy launch and double booster recovery was just epic.
And like I mentioned on Monday, it was actually the very first SpaceX launch that I had ever seen. And after that unforgettable demonstration flight, Falcon Heavy moved on to operational missions. In November of 2022, USSF-44 became the first classified national security launch on Falcon Heavy, placing sensitive payloads into high-energy orbits. And in 2023, Falcon Heavy launched the ViaSat-3 Americas mission. Then there was the Psyche mission, which launched later that same year, which sent NASA...
RP1 load complete.
There was a good call-out. Then the Psyche mission launched later the same year, which sent NASA's spacecraft on a journey to study a metal-rich asteroid, providing valuable data on planetary formation.
And Falcon Heavy's most recent flight in October 2024 carried NASA's Europa Clipper spacecraft toward Jupiter's moon Europa. And that mission required the full performance of Falcon Heavy to achieve the necessary escape trajectory. And that all brings us to today's mission, with Falcon Heavy poised to carry the ultra-high-capacity ViaSat-3 Flight 3 satellite to orbit.
Like Falcon 9, Falcon Heavy is a two-stage launch vehicle.
Falcon Heavy's 27 Merlin 1D engines together generate more than 5 million pounds of thrust at liftoff. And to put that in perspective, that's equal to about 18 747 aircraft. Shortly after liftoff, the center core engines will throttle down, and after the
PY RP1 load complete.
After the two side boosters separate, those center core engines will throttle back up to full thrust. And we also just heard confirmation that one of the side boosters has wrapped up RP1 loading.
Now, starting from the very top of the rocket, we have the payload fairing. The fairing is a protective shell that houses the payload, shielding it from aerodynamic heating until the vehicle is safely outside of Earth's atmosphere. The shape of the fairing contributes to Falcon Heavy's overall efficiency, helping to reduce drag during flight.
Engine chill has started.
And then once in space, the two fairing halves separate and fall back to Earth for an ocean landing, where they'll be recovered by our recovery vessel to be refurbished and reused on future flights.
Both halves of this fairing are flight-proven. One side is flying for its 25th time, and the other for its 18th. And within that fairing is, of course, today's payload. ViaSat-3 Flight 3 arrived in Florida in April to begin its pre-launch preparations and checkouts before being mated with Falcon Heavy's
NY RP1 load complete.
second stage, and there's that other side booster wrapping up RP1 load. Here you're looking at a photo from midway through the encapsulation process, taken just before the fairing halves were closed in preparation for flight.
And right below the fairing is Falcon Heavy's second stage, which houses the MVAC engine. Below the second stage is the black carbon composite inner stage, and inside of that is where the MVAC engine is located. The inner stage connects the center core on the first and second stages and holds the release and separation system.
And below that, we have those three first stage boosters, which make up the bottom two-thirds of the vehicle. These side boosters supporting today's mission are both flight-proven. One is flying for its 22nd time, and the other for its second. One side booster previously supported the SDA-0A, Sarah-2, Transporter 11, and 18 Starlink missions, and the other supported the GOES-U mission. As mentioned earlier, about 2.5 minutes into flight, these side boosters will separate and make their way back to Earth to perform near-simultaneous landings at landing zones 2 and 40 at Cape Canaveral Space Force Station.
Now, coming up next, support structure next to the vehicle, known as the strong back or the transporter erector, will start to retract. And in preparation for retraction, those clamp arms around the second stage will slowly open, and then the strong back can recline away from the vehicle.
Falcon Heavy tanks are pressurizing for strong back retract.
Good confirmation there that we're tracking towards strong back retract. And the strong back plays a very active role in the launch process, not only transporting the vehicle and raising it vertical, but it also is equipped with umbilicals and flex lines that are used to route the vehicle's fluids, power, and command connections between the ground systems and the rocket until Falcon Heavy switches to internal power.
Strong back retract has started.
And in the next few seconds, we're going to start to see those arms coming open. And once they start that process, it's going to take about 15 seconds for them to fully open. And then once they're out of the way, the strong back is free to recline away from the vehicle a couple of degrees and then give it room for liftoff. You can see them start to open now. And now that those clamp arms are fully open, the rocket is fully free at the top. We should start to see that strong back.
NY, LOX load complete.
There's a good call out that one of the side boosters is now complete with its LOX load. So it is fully loaded with all of its propellants. And if you look at the strong back on the right,
LOX load complete.
we're now fully loaded with LOX on the other side booster now. You can see that strong back has moved back a little bit. And as we mentioned earlier, this is our first Falcon Heavy flight since 2024, and a lot is going to happen in the first 4 minutes of flight. First, we'll light the two side boosters, followed by the center core. Then, about 40 seconds after liftoff, we'll decrease power on the 2 side boosters in preparation for max Q. At about 2.5 minutes into flight, the side boosters will shut down during the booster engine cutoff, or BECO, and the boosters will separate. Once clear of the side boosters, the center core will throttle up once again until the center core shuts down with main engine cutoff, or MECO. Meanwhile, the side boosters
Center core LOX load complete.
And there we just heard the call out that the center core liquid oxygen loading is complete. So at this point in time, both side boosters and the center core are now fully loaded with liquid oxygen and RP1. We're still loading liquid oxygen on the second stage, and that should conclude at the T-minus 2 minute mark, which will also conclude all propellant loading for Falcon Heavy.
And we're coming up on about 10 seconds away from wrapping up that last propellant load milestone.
Stage 2 LOX load complete.
Right on time. So with that, Falcon Heavy is now fully loaded with nearly 3 million pounds of propellant. Coming up next in the launch countdown will be ground gas closeouts. It's about 20 seconds from now. Looking ahead a little bit, at the T-minus 1 minute mark, Falcon Heavy will enter startup, and the onboard flight computers will take over the launch countdown.
Ground gas closeouts.
You may be able to hear and certainly see an increase in white cloud venting, and this comes from venting down the TE liquid oxygen fill line. Now we're heading towards that T-minus 1 minute mark, at which point Falcon Heavy will enter startup.
Falcon Heavy is in startup.
Stages 1 and 2 will now begin to pressurize for launch.
Launch director, go for launch.
At T-minus 40 seconds, all systems are go for launch. Let's listen in to the final seconds of the countdown.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon Heavy, go ViaSat.
M1D chamber pressures are nominal.
Vehicle is pitching downrange.
At T plus 30 seconds into flight, Falcon Heavy has successfully lifted off from Launch Complex 39A at Kennedy Space Center. We're now throttling down the engines to prepare for max Q, which is the point of maximum aerodynamic pressure during ascent. Max Q occurs when the combination of speed and air pressure puts the greatest stress on the vehicle.
Falcon Heavy is supersonic.
And there we just heard the call out that the vehicle is now traveling faster than the speed of sound. Max Q coming up in a few seconds.
Max Q.
Now we've passed the moment of peak mechanical stress on the rocket, and M1D engines are throttling back up.
Now we have several events coming up and a few more than we're accustomed to with Falcon 9 missions, so let's get into it. First will be BECO, or booster engine cutoff, when the engines on the 2 side boosters shut down. After that, the side boosters will separate from the center core and perform a flip maneuver using their small thrusters to head back towards Earth. Next, the side boosters will initiate boost back burn to send the vehicles towards landing zones 2 and 40. After that is main engine cutoff, or MECO, when all the engines on the center core shut down, and that will be followed by stage separation, where the center core and second stage are pushed apart. A few seconds later, we'll see that second stage MVAC ignite to continue to carry the payload to orbit. And finally, once in space, the fairings will be deployed from stage 2. And we're about 15 seconds away from the start of that sequence of events. First, again, we're looking out for BECO, side booster separation, booster flip, and boost back burn startup.
Booster engine cut off.
Side booster separation confirmed.
And back chill.
NY and PY boost back startup.
Great news. At this point, both Falcon Heavy side boosters are performing the boost back burn. And this is the first of 3 burns that each side booster will undergo on the way back to Cape Canaveral Space Force Station. The primary objective of this burn, the boost back, is to quickly reorient the side boosters onto the required return trajectories. And that's particularly important in the event of a return to launch site like today, as opposed to a drone ship ocean recovery. These boosters are heading towards landing zones 2 and 40. Meanwhile, on the center core, the 9 M1D engines are continuing to power Falcon Heavy on its nominal trajectory and throttled back up following booster separation. We're about 20 seconds away from boost back burn shutdown, at which point the boosters will continue to coast until they restart for entry burn. Coming up next, we're standing by for the boost back burn shutdown, which will be followed by main engine cutoff on the center core, stage separation, and second engine start 1 of the MVAC engine.
NY and PY boost back shutdown.
Main engine cut off.
Stage separation confirmed.
And back startup.
Fantastic news and a great view there on your screen following stage separation, and we're now looking out for fairing separation.
All vehicles are following a nominal trajectory.
Fairing separation confirmed.
Great view there of the fairing in the background, and after those action-packed few minutes, we had 2 side boosters separate, perform their flip maneuvers after engine shutdown, followed by a complete boost back burn. The center core had its own engine cutoff right before it separated from stage 2, and that was followed by the first engine start on the second stage, as well as a successful fairing separation.
Now, the next major milestone coming up is entry burn on our 2 side boosters, scheduled to occur just after the T+ 6 minute and 30-second mark. The entry burn is used to slow the first stage boosters as they head back towards landing zone 40 and landing zone 2. Now, we're currently in our first MVAC burn, and this burn should last for another few minutes. The next milestone will be the first stage entry burn, coming up in about 2 minutes. Today, Falcon Heavy side boosters will be performing 2 burns in order to land. The first burn, known as the entry burn, slows the vehicle down before hitting the denser parts of Earth's atmosphere.
Without this entry burn, we'd only be using atmospheric drag to slow down Falcon Heavy's side boosters, which would add extra stress to the vehicle.
Stage 1 FTS is saved.
Following the entry burn, the boosters will initiate a landing burn to slow down even more for a precise touchdown. When Falcon Heavy's side boosters fire up their center M1D engines for re-entry, the vehicles will be flying through Merlin's exhaust gases, also known as the rocket's plume, and that process deposits a layer of soot on the vehicle's surface. The soot actually comes from the carbon-based fuel, RP1, that Falcon Heavy uses, and with each flight, that layer builds up a little bit more on the outside of the vehicle.
Now, in about 20 seconds, those side boosters will execute the entry burn, followed by the landing burn. Both burns are meant to slow the side boosters down rapidly before landing. At the time of separation, the side boosters were traveling slow enough to turn around and make their way back to land at our landing pads. So we're expecting entry burn in a few seconds.
NYPY entry burn startup.
And there's the call-out for the entry burn startup for the Falcon Heavy side boosters. This burn is set to last about 15 seconds and again is slowing those vehicles down in preparation for their final burn and landing.
NYPY entry burn shutdown.
And that concludes our entry burn. As mentioned earlier, we will be attempting to recover both side boosters, which are targeting landings at landing zone.
All vehicles continue to follow nominal trajectories.
Great news there. We're targeting landings at landing zones 2 and 40 at Cape Canaveral Space Force Station. And you can continue to follow along with the upcoming landing burn with the engine graphics at the bottom of your screen.
FTS is saved.
Landing burn is coming up in about 20 seconds.
FTS is saved.
Meanwhile, you can see on stage 2 that first burn of the MVAC engine is still underway. ViaSat-3 Flight 3 is on its way to orbit.
Transonic.
Stage 2 FTS is saved.
Stage 2 is in terminal guidance.
Expecting that landing burn startup in just a couple seconds. Landing burn has started up. This is the final burn before the boosters will touch down.
Landing light deployed.
The Falcons have landed. As you saw, we had successful landing of Falcon Heavy side boosters. If you were in the vicinity, then you definitely heard those sonic booms on their way down. Now,
shut down.
We just heard the successful cutoff of our second stage engine, and we are waiting for confirmation of good orbit.
Nominal orbit insertion.
And there was the call out. Now, we have a bit of a breather coming up before the next milestone for the mission, which is SES-2, when the MVAC engine on the second stage restarts as it continues to its orbital destination. That's going to come up at the T plus 26 minute mark, so we're going to take a break and leave you with some fantastic views. So see you back here in about 15 minutes.
Então é isso, pessoal. Como eu comentei com vocês, então hoje só iremos transmitir neste momento, né? Não poderei transmitir toda a missão, né? Então fique com a SpaceX, né? O site oficial da SpaceX. E aí vocês poderão então terminar de acompanhar esta missão ViaSat-3 F3. Né? Muito obrigado pela companhia, pela audiência e nos vemos numa próxima transmissão. O Wilpa TV sempre mostrando então tudo o que acontece ao redor do mundo e na Estação Espacial Internacional. Até mais!